In this video, we're going to talk about how to use the limit definition of derivative, which we discussed in the previous video, to find derivatives. Now, let me warn you, this is a bit of a lengthy process, and it's something you need to be able to do, even though, for the most part, when you find derivatives, you're going to be using techniques which are much quicker. We're going to go over this just for your knowledge. It is important that you know where the definition of where the idea of derivatives comes from, and it's important that you have this in the back of your mind. Alright, so the function we're given is 2x minus x squared. So to find f prime of x, what we need to do is find the limit as delta x tends to 0 of f of x plus delta x minus f of x all over delta x. Now, there are actually two different variables here. There's x and there's delta x. They are completely different. They are independent of one another even. So, let's talk about how to evaluate this. Alright, so this first part of this difference quotient, I think of the difference quotient as consisting of three parts. There's the f of x plus delta x, there's the f of x, and there's the delta x. The first part, the f of x plus delta x, that's what you get when you substitute in x plus delta x for every x in the function you're given. So you would have 2 times x plus delta x minus x plus delta x squared. Then we're going to subtract off the original function, and then we're going to divide the whole lot by delta x. Alright, so what we need to do at this stage is simplify this. Alright, so I'm going to rewrite this x plus delta x squared as x plus delta x times x plus delta x. Well, I'm going to simplify some of this other part too. I'm going to distribute the 2 across here. That's going to be 2x plus 2 delta x minus x plus delta x times x plus delta x. And I'm going to distribute this negative across here, so that's going to give us minus 2x plus x squared. Something's wrong. I should have a delta right in there. I'll rewrite that so you can see it more clearly. Alright, so let's continue. If you'll notice, you've got a 2x and a minus 2x. Those are going to add up to 0, so I'm going to just get rid of those. And so we're going to have 2 delta x, and now I'm going to multiply x plus delta x by x plus delta x. So x times x is x squared, but we're subtracting, remember. And then you're going to have x times delta x, but then you're going to have another x times delta x. So that's 2x times delta x, but again you're subtracting, so that's minus 2x delta x. And then you're going to have delta x times delta x. That's the square of delta x. But remember we're squaring, so I'm going to write that as minus, and I'm going to put the delta x in parentheses, and that's squared. And let's see, the 2x went away previously. All right. So this is going to simplify some more. You've got a minus delta x and a plus delta x. Those are going to add up to 0. And that'll leave us 2 delta x minus 2x delta x minus delta x squared, and that's all over delta x. Now at this stage you may be tempted to substitute in 0 for delta x, but if you do that, each term up here will go to 0, and so you have 0 in the numerator and you'll have 0 in the denominator. That's an indeterminate form. That means there's more to be done. And in this case what we can do is take out a common factor of delta x. And that'll leave us 2 minus 2x minus delta x all over delta x. That's convenient. The delta x's go away, and so we're left with just the limit as delta x tends to 0 of 2 minus 2x minus delta x. We're practically finished. We're very close to being finished. At this stage, all we need to do is substitute in 0 for delta x, leaving us 2 minus 2x. That is f prime of x. Now, if you've seen derivatives before, you may be complaining about how horrible this is, and, oh, can't we do this the short way? Yes, you can do this the short way later, but if you're taking my calculus class, there's a good chance that you will be asked to find the derivative using this technique, and so you need to know it.